Hey, welcome. This video is on logarithmic equations. Let's start with the definition of a logarithm. For all positive numbers b, where b cannot equal 1, and all positive numbers r, so b and r must be positive. That's going to be important in a lot of the equations that we solve. B to the t equals r is equivalent to log of r with the base b equals t. This abbreviation of log is used for logarithm. And this log r with base b, that's a couple different ways you could read it. You could say log base b of r, or log of r with a base of b. So we have this diagram. To the left we have exponential form. That's b to the t equals r. So that's exponential form. And on the right we have logarithmic form. Log of r with a base b equals t. Same letters. B stands for base. The letter t is the exponent. I use the variable r here, so sometimes I'll call that the result, because that's a result of b to the power t. So the meaning. A logarithm is an exponent. Log r base b is the exponent on the base that yields the number t. Okay, so a logarithm just gives us the exponent. We can use the definition of logarithms to write exponential statements in logarithmic form and logarithmic statements in exponential form. So we could go back and forth. That's the point, to solve more equations. Okay, a logarithmic equation is an equation with a logarithm in at least one term. Our objective here is to show how changing from logarithmic form to exponential form will enable us to solve other types of equations. So if we have it in logarithmic form, we're going to change it to exponential form. All right, so here's our procedure. To solve equations of the form log of r base b equals t, step 1. Write it in exponential form by using the definition of a logarithm. Log of r base b equals t is the same as b to the t equals r. So we're going to change it from logarithmic form to exponential form. And then we're going to use a property we talked about previously. If b is greater than 0, not equal to 1, m and n are real numbers, then b to the n equals b to the m if and only if n equals m. What that statement says is if the bases match, then the exponents match. It also says if the exponents match, then the bases have to match. So that's that if and only if. It goes both ways. All right, here's our first example. Log of 16 base 2 equals x. So let's change that to exponential form. Right now it's called logarithmic form because it has a log. So what would that be in exponential form? Well, which one is the base? The base is that lowered number, right? That's the 2. And the exponent is the t, so that's all the way on the right. So that's our x. And then r, that comes after the base next to the log, that's 16. So that gives us 2 to the power x equals 16. Can we match bases? Yeah, we could do it. 16, we want to rewrite 16 using the base of 2. 2 to what power is 16? Right, 4. So now we have the bases matched, therefore the exponents have to match. So our answer is 4. That's it, not too bad so far. All right, here's 2 more. I think you could probably do these on your own, so why don't you pause the video, work them both out, and then come back when you're ready. All right, exponential form. So that would be 6 to the x equals 216. Now 216, if you're not sure, just get your calculator out and type in a number so we could see if we could match it with 6. So you know it's not 2 because 6 squared is 36. Could it be 3? Yeah, you type in 6 to the power 3 and it does give you 216. So now we have our answer, x equals 3. All right, the next one, same thing, exponential form, so that would be 5 to the x equals 1 over 25. The 1 over 25, we could use a base of 5, right? 5 squared is 25, but we need to bring it up to the numerator. That means a negative exponent. So that's x to the negative, so x equals negative 2. Right, because if you type in 5 to the negative 2, you'll get 1 over 25. Now also keep in mind, many calculators you could put in your own base, so you could probably type in log 216 base 6, and it should work out just fine. Okay, our next example, log of 1 over 81 base 3 equals x. Okay, if you think you could do it, pause the video and work it out. All right, first we're going to change it to exponential form, right? That would be 3 to the power x equals 1 over 81. So 81, can we rewrite 81 with a base of 3? Yeah, we can, right? 3 to the power 4. Okay, but the 3 to the power 4 is in the denominator, so how do we bring it up to the numerator? Yeah, we just change the sign of the exponent from positive to negative. So what's our answer for x? Yeah, negative 4. All right, here's our next one. When we solve these examples, I just wrote the definition here to the side. Just keep in mind that r has to be positive and b also has to be positive. So what we're looking for is r here. It's not a big deal in this example, but we're going to do some other problems later on where we have to really be careful that r or b is not negative. If we do get a negative, then we would have to discard that solution. All right, let's write it in exponential form. What would that be? The base is 27. The exponent is 2/3. A fraction equals x. Now, if you could use a calculator, you could probably just type in 27 to the 2/3. If you can't use a calculator in your class, then you can write that in radical form. So you put the 27 in a radical. The 3, the bottom number, is your index, and the 2 goes outside the parentheses. So that's how you would write it in radical form. So it's a cube root of 27 all squared. What number times itself 3 times is 27? Yes, 3. 3 times 3 times 3. And then we have to square it. So our answer is 9. And that's a positive, so r is positive. No big deal there. All right, this one's very similar to the last one. Why don't you pause it again, work it out. All right, exponential form. That would be 8 to the 4/3 equals x. Write that in radical form. So cube root of 8 to the 4th. Cube root of 8 is 2. So 2 to the 4th would be 16. All right, next example. Oh, this time, where is the variable located? The variable is located where the base is. So keep in mind that the base must be positive. Right? If we look at the definition, it says for all positive numbers b. I know when we're reading this, it's kind of hard, like, what does that all mean? But b means it has to be a positive value. Okay, let's change it to exponential form. X to the 1/2 equals 4. Now there's a couple different ways you could do that. Again, we could write that in radical form. So let's do that here. The 2, the bottom number is your index. The 1 goes outside the parentheses, so it's a square root of x to the power 1. Well, the power of 1 doesn't mean anything, right? And it's always assumed to be a square root of x. So that just means square root of x. Now, how do we solve an equation with a square root? Do you remember? Right, we square both sides. You square both sides to get rid of the square root. So on the left side, the square and the square root cancel each other out. And we're left with 16. So there's our answer. That's a positive value. Again, it's all good. Here's another one very similar to the last example. Again, we'll write it in exponential form. So that would be x to the 1/2 equals 5. Now I'm going to solve it a little different this time. We want to get rid of the 1/2, right? Well, we could go right to squaring both sides. Because there's a rule, x to the a raised to the power b is equal to x to the ab. So if you multiply 2 times 1/2, what do you get? You get x. The 2 times 1/2 is just 1. Okay, so we still do the same thing we did in the last example. You square both sides to get rid of a square root. If that was a 1/3, then we would cube both sides to get rid of the 1/3. If that was a 1/4, then we would raise each side to the 4th power. All right, so this one, the answer is 25. That's a good answer. Let's move on. Okay, again, our variable is where the base is. This time it's not a fraction on the right-hand side. So let's write this in exponential form. That would be x squared equals 9. Now, how do you solve that? Well, you have two options. You could either subtract 9 on both sides and then factor, or you could use the square root property. So I'm going to choose to use the square root property. That'll always work in this kind of situation. So square root property means that we get rid of the squared on the left side, and on the right side we put a plus and minus square root of 9. All right, what's the square root of 9? 3. So we get plus and minus 3. Two answers. Are they both answers? No, because the base can only be positive, so we are going to omit the negative. So our answer is only 3. And there's a note there. The base must be positive, therefore the negative solution is omitted. So sometimes people forget the plus and minus anyways, so if you did, I guess that's a good mistake. But if you don't forget, and you put the plus and minus, then you want to realize that we cannot have a negative base here. So if it's negative, you must omit that answer. So just positive 3. All right, very similar to the last one. Again, you should pause it, work it out. All right, exponential form. X squared equals 50. Square root property. So what do we get? X equals plus and minus the square root of 50. Can you simplify the square root of 50? Yeah, that's 25 times 2, or 2 times 5 times 5. So there's a pair of 5s. A 5 comes out, a 2 stays inside. So x equals plus and minus 5 square root 2. Again, we need to omit the negative solution, so our answer is only 5 square root 2. Again, the base must be positive, therefore the negative solution is omitted. All right, this was not exactly an equation because it just says evaluate. Equations should always say solve. So this one says log of 64 base 2, and we want to evaluate that. Well, what we're going to do is we're going to kind of cheat a little bit, and we're going to make it an equation. So you set that equal to x. All right, now it looks familiar, right? So now we're going to change it to exponential form. That would be 2 to the x equals 64. Match our bases. Yes, 2 to the 6 is equal to 64. So what does x equal? X equals 6. So when you write your answer, you don't want to box x equals 6 because there was no x in the original problem. So when you box your answer, you should write the original expression and then put what it's equal to. So log 64 base 2 is equal to 6. Okay, log of 0.001 base 10. Same thing, we're going to let it equal x. So log of 0.001 base 10 equals x. Write it in exponential form. That's 10 to the x equals 0.001. Now we're going to try to match the bases. So let's see, that number on the right, 0.001, what position is the 1 in? Right, it's in the thousandths place. Remember, the first place after the decimal is tenths. The second number after the decimal is the hundredths. The third place is the thousandths. All right, so that number is 1 over 1,000 because it's 1,000th. Now, 1,000 is 10 to a power. It's not 10 squared. 10 squared is 100. Is it 10 cubed? Yeah, 10 cubed is 1,000. So 10 to the x equals 1 over 10 cubed. How do we bring the exponent up, the whole term up? Right, a negative. So therefore our answer is -3. All right, here's another one. Log square root 5 base 5. Let it equal x. Write it in exponential form. So 5 to the x equals square root 5. Now we want to match bases. Let's see, on the right, square root of 5, that's the same thing as 5 to what power? Yeah, hopefully it's 1/2, because you know how to work backwards. If we have 5 to the 1/2, we could go back and write it in radical notation, but now we're going from radical notation to exponential notation. So 5 to the 1/2 is the square root of 5. So now we got our answer. X equals 1/2. All right, this one's very similar. It's just getting used to writing the radical in exponential form. All right, here we go again. 3 to the x equals the 4th root of 3. What will that be? 3 to what power? Yeah, the exponent outside the parentheses, well, there's no parentheses, right? So you could always think of it as a 1. So this would be 3 to the 1/4 power. Now we got our answer, 1/4. Okay, this looks interesting. Log 7 base 7, they're the same number. Let it equal x. Change it to exponential form. So 7 to the x equals 7. What could it possibly be? 7 to what number is going to give you the same number? Yeah, you got it. It has to be 1. There's no other option. So we could write a 1 there if we want to, but you could have skipped that step. You could have went right to x equals 1. Okay, so this is going to be true. Doesn't matter what these numbers are. If b and r are the same numbers, it's always going to equal 1. And that's actually a property. For any positive real number b, we know that b to the 1 equals b. So writing in logarithmic form, that gives us the following. For any positive real number b not equal to 1, so as long as b is not 1, the log of b base b is equal to 1. Okay, here's another one. This one looks interesting too. Log of 1 base 9. All right, write it in exponential form. That gives us 9 to the x equals 1. Right? 9 to what power gives you 1? It can't be 1 because 9 to the 1 is going to give us 9. It can't be a -1 because that'll give you a fraction. 9 to the -1 is 1 over 9. Yeah, what's your guess? Yeah, 0. That's it, 0. What's anything to the power of 0? 1, exactly. 9 to the 0 is 1. 5 to the 0 is 1. So we could write it as 9 to the x equals 9 to the 0. So therefore, x equals 0. But this gives us another property. So same thing. As long as b is equal to 1, the log of 1 with a base b is equal to 0. So anytime you have a 1 where the result is, it's equal to 0. All right, log 15 base 3. This one says round 4 decimal places, so we're definitely going to have to use our calculator. All right, let's set it equal to x. Now change it to logarithmic form. Excuse me. Change it from logarithmic form to exponential form. So that gives us 3 to the x equals 15. Now, can we match the bases? No, because 3 to a power is not going to give us a 15. That's why in the directions it says round to 4 decimal places. That's kind of a key to tell you we're going to need a calculator. All right, so we've done this previously. We're going to take the log of both sides, and then we're going to use the power rule. So right now, just put log in front of each side. Log of 3 to the x equals log 15. Now on the left-hand side, you could bring the x in front of the log. That's the power rule. So I wrote it here just in case you forgot. If r is any real number, b is a positive real number other than 1, and p is any real number, then there it is at the right. Log of r to the p base b is equal to p times log of r base b. So that power b, p, goes in front of the log. So that x goes in front of the log 3. Now to solve, we're going to divide by log 3 on both sides. And if you notice, it's still the same numbers we started with. We just kind of wrote the result on top, log of the result on the bottom, and log of the base on the, sorry, I said that wrong. Log of the result on top and log of the base on the bottom. There's actually another name for this. It's called the change of base formula. But there's so many things to remember, I'd rather just work through the problem. All right, type that into your calculator, and you should get 2.4650. All right, here's our next one. Log of x equals 0.2956. So this is a little different. The 0.2956, that's actually the exponent, right? A logarithm is an exponent. So we actually just want to know, what does it give us? Now, it doesn't have the base written, so what is it equal to when the base is not written? It's equal to a 10. The base is a 10. So this is the log of x base 10 equals 0.2956. Change that to exponential form. So what would that be? That would be 10 to the power 0.2956. Okay, now that's all we have to do. Put it in our calculator. You have two options on your calculator. You could either type 10 and then your exponent button and then the 0.2956, probably the way we would normally do it. On some calculators, there's a log button, and above that log, there's a 10 to a power already there. You might see that on your calculator. So it's called an anti-log. It's another name for it. Anyways, whichever way you feel comfortable doing it. So you could hit the shift and then your log button, and there's a 10 there. All right, type that in, and you should get 1.9751. Here's another one, just from our practice. Again, same thing. Put that base in. If it's not written, it's a 10. Exponential form, 10 to the negative 1.35. Type it into your calculator. And we're going 4 decimal places, 0.0447. Okay, these two problems here have the natural logarithm, the ln. The only thing about natural log is its base is different. Do you remember what the base is? Right, the base is assumed to be e. So let's write that in. Ln of x of base e equals 3.4. Change it to exponential form. E to the 3.4 equals x. Then you just type that into your handy dandy calculator. Most calculators, it should look like an e to the x or an e with a little box. It should be by the same key, the ln button. You might have to hit shift or second on your calculator. All right, so you get 29.9641. All right, example 21, same process. Ln of x base e equals negative 2.57. Change it to exponential form. And then type that into your handy dandy calculator. And you get 0.0765. Okay, we have two more properties of logarithms. The product rule and the quotient rule. So the product rule says that if you have the log of x plus the log of y, it's equal to the log of x times y. So we're able to take two logarithms and condense it to a single logarithm. If there's a plus in the middle, we just write it as a product of the two results. The quotient rule, well, that's if there's a minus in the middle. If there's a minus in the middle, then we write it as a fraction of the first result over the second result. So log of x minus log of y is equal to the log of x over y. So for all these numbers, they all have to have the same base. Base can't be equal to 1. So this is going to allow us to solve more kinds of equations. Then we're going to change from logarithmic form to exponential form to solve the equations. All right, here's our first example. Log of x base 5 plus log of 3 base 5 equals 2. So there's a plus in the middle. Product rule or quotient rule? Right, product rule. So that gives us the log base b, in this case it's 5, log base 5 of x times 3. I wrote 3 times x just because it looks better. So now we're going to change it to exponential form. That would be 5 to the power 2 equals 3x. Now we could solve. 5 squared is 25. And I put the 3x on the left-hand side because I'm more accustomed to solving equations with my x on the left. Now divide both sides by 3, and we end up with 25/3. There we go, that's our answer. So if you see a plus in the middle, product rule, a minus in the middle, quotient rule. Also keep in mind, if you have logs on both sides, you can move a log from one side to the other by changing just the sign in front. So let's say this log of 3 was on the right-hand side. It said 2 minus log 3. You could move it over to make it look the way it does and just change it to a plus. All right, here's our next example. Log of 4 base 3 minus log of x base 3 equals 2. Quotient rule, right? It's got that minus in the middle. So if we use the quotient rule, log of 4 over x, the first result over the second result, same base. Now we're going to change it to exponential form. 3 squared equals 4 over x. What does 3 squared equal? Right, 9. Now you could put a 1 under the 9 and then cross multiply. That's probably the easiest way to solve this. Or you can multiply both sides by the LCD. But cross multiplying, that gives us 9 times x equals 4 times 1, so 9x equals 4. And then divide by 9 on both sides. So we get 4/9. Now, we also talked about r and b have to be positive. So we got 4/9 here. That's a good answer. If we would have got negative 4/9, remember that you cannot have the log of a negative number. So if that was a negative 4/9, we would say no solution, but 4/9 is fine. All right, product rule or quotient rule. It's got a plus in the middle. Yeah, product rule. So that's log of x times x minus 7 base 2 equals 3. Change it to exponential form. So 2 to the third equals x times x minus 7. 2 to the third is 8, and then distribute on the right, that's x squared minus 7x. All right, we're going to need a factor, so move the 8 over to the left to get 0 on one side, so that gives you x squared minus 7x minus 8 equals 0. Now we could factor. How does that factor? The only factors of 8 are 8 and 1, and 2 and 4. 8 and 1 will subtract to be 7. So it needs to be a negative 8 and positive 1. So we have two answers, 8 and negative 1. Now, are they both good answers? So let's look at the negative 1. Negative 1 has to be rejected, because if you plug it back in, log of negative 1 base 2 plus the log of negative 1 minus 7 equals 2. If you try to type in log of a negative number, it's going to say math error, not possible, something like that. So I don't want you to think that it can't be a negative number. It can't be a number that gives us the logarithm of a negative number. For example, let's say we got an answer of x equals 5. X equals 5. If you go back to the original problem and plug in 5, the first logarithm, that one's going to be fine. But the second one, if you replace x with 5, what's 5 minus 7? 5 minus 7 is negative 2, and we can't have the log of a negative number. So you would have to reject 5 as well. So remember that you have to be able to plug these numbers back in and not get a negative. All right, so the -1 is rejected, so our answer is only 8. So on a test, if you left -1 for your answer, you would probably be marked down. So make sure that you cross out answers that result in the logarithm of a negative number. All right, this problem is very similar to the last one. You should pause the video and try to work it out. Okay, we have to use the product rule, right? Because there's a plus in the middle. And then change it to exponential form. On the left, 6 squared, that's 36. On the right, we need a FOIL. So 36 equals x squared minus 4x plus 1x minus 4. Add our like terms. And also bring the 36 over to the left. Sorry, the right. So to get rid of the 36, you minus 36 on both sides. That'll give you a -40. Okay, I might rewrite it because I like the 0 on the right-hand side. So x squared minus 3x minus 40 equals 0. We need a factor. Factors of 40, that's subtract to be 3. Yeah, that would be 5 and 8. A -8 and a +5. So we got two answers. We got x equals 8 and x equals -5. Do they both work? 8's good. How about -5? No. So our answer is only 8. Here's another one. This one is also the product rule, right? This one looks different though, right? What's missing? Right, the base. What is the base when it's not written? It's a 10. So always remember that the base is 10 if it's not written. All right, now we could change it to exponential form. So that gives us x squared minus 15x minus 100, because 10 squared is 100, but when you bring it over, so 100, 20 and 5, I think so. Yeah, 20 times 5, minus 20 plus 5. That gives us two answers, 20 and -5. Which one doesn't work? Right, the -5. So our answer is only 20. Okay, hang in there, we're almost done. Okay, so we've talked about this property, putting the log in front of both sides. So x equals y if and only if the log of x equals the log of y. What that means is if we have two things equal to each other, we could put log in front of both sides, and we've been doing that. But also, whenever they say if and only if, it means that the statement goes in both directions. So that means if we have the log of x equals the log of y, and they have the same base, then the two results must be equal. Okay, I know that's strange, but we'll see how that works out. Here's our first problem. Log of x plus 2 equals log of 3x minus 12. Now, I didn't write the base. It's assumed to be 10, but it doesn't matter what it is. I could have put a base of 6, as long as it's the same base on each side. So as long as we have log on both sides, that means the results have to be equal. So that gives us our equation, because we're going to use this property. If the log of x equals the log of y, then x equals y. So x plus 2 equals 3x minus 12. All right, solve that equation. Get x by itself on one side. So if you subtract 3x on both sides, you're going to get negative 2x on the left, and if you move the 2 over, you're going to get negative 14 on the right. I know I probably skipped a couple steps here and there, so always take your time and work it out for yourself. Then divide by negative 2 on both sides, and that'll give you x equals 7. So let's think about 7. Make sure it's okay. Remember, the domain can only be positive numbers. The domain for a logarithmic function is only positive numbers. So we just need to make sure that we only get positives if we plug it back in. Let's see, 7. 7 plus 2 is 9, so we got log of 9 on the left. And then on the right, 3 times 7 is 21, and 21 minus 12 is also 9. So that makes sense, 9 and 9 on each side, and they're both positive. So our answer is good. So we could box our answer and feel good about it. This one doesn't have the base written as well. This time it's a minus sign in the middle. What does that mean we're going to use? Right, we're going to use the quotient rule. All right, so that gives us the log of 5x over 2x minus 1 equals the log of 4. Again, we have log on both sides. So since we have that, that means our two results must equal. Some teachers will show students to cross out the logs. It's okay. It's not really technically correct, but it's okay. So now we have 5x over 2x minus 1 equals 4. Now put a 1 underneath the 4 and then cross multiply. So 5x times 1 is going to go on the left, and 4 times 2x minus 1 is going to go on the right. Now we distribute on the right. 5x equals 8x minus 4. Subtract 8x on both sides. And then divide by negative 3. So we get an answer of 4/3. 4/3 is a positive number. It's bigger than 1. So we're going to go back to the original problem and kind of plug it back in. 5 times 4/3. Is that going to give you a positive number? Yeah. And then 2 times 4/3 minus 1. Well, again, 4/3 is bigger than 1. Let's just pretend it's 1. What's 2 times 1? 2 times 1 is 2. And 2 minus 1 is 1. So we still get a positive number. So that checks out. We could feel good with that answer. Let's say we got an answer of, I don't know, 1/3. Let's say it was 1/3. If we plugged in 1/3, well, 2 times 1/3 is 2/3. And then 2/3 minus 1, that would be a negative number. So 1/3 would not be an acceptable answer. But 4/3 is. So we'll move on. Hey, all right, last problem. You made it. Log of x base 5 plus the log of x minus 21 base 5 equals the log of 100 base 5. What are we going to do first? Right, it's got a plus in the middle, product rule. All right, so again, if the log of x base b equals the log of y base b, then x equals y. Doesn't matter what the b's are. So we're going to use the product rule first. That gives us the log of x times x minus 21 base 5 equals the log of 100 base 5. So again, as long as we have the same log on both sides, we just get rid of it. So it's x times x minus 21 equals 100. Distribute on the left. Bring the 100 over from the right to the left, changes to a negative. Now we have to factor that. Let's see, 100 4 and 25? Yes, x minus 25 times x plus 4. So we got two answers. We got positive 25 and negative 4. Let's see, the negative 4, probably not, right? Yeah, look back at the original problem. Yeah, that's not going to work. So we're going to get rid of that one. So our answer is only 25. That was it. You made it. I'll see you here for the next video.